unlike humans, robots are not limited to just sight, sound, touch, smell, and taste senses. We just have six senses in total, but robots are not like that. So robots use variety of different electromechanical sensors to explore and understand their environment and themselves. So emulating a living creature's sensors is currently very difficult. So researchers and developers have resorted to alternatives to biological sensors. About the new technology in sensors is that researchers and developers are started to build more biological sensors, not by using complete electrical mechanisms, but they also use biological parts and bio nanotechnology also. So robots can see but have a hard time understanding what they are looking at, because using a camera, a robot may be able to pick up an image which is made up of millions of pixels, but without significant programming, it would not know what any of those pixels means, or what the image that it sees is or actually about. So distance sensors would indicate the distance to an object, but would not stop a robot from bumping into it. So that's how sensors and programming or microcontrollers are being used together. So, anyways, robots have really hard time while tasting and smelling senses, because a human may be able to tell you this tastes sweet and this smells bad. But whereas a robot would need to analyze the chemical composition, and they look up to a substance in a database which is stored into them to determine if humans have marked the taste as sweet or the smell has been bad. So that's how a sensor works. So using just a sensor is simply, and what to be more precise, we can we can say it as senseless human. So people call senseless human because they many people have senses, but they won't use it properly, and they won't understand their environment and themselves properly. That's why we scold some humans as a senseless beings. So that's how the same robot also works like. So only sensors being used in a robot is just a machine which has nothing but sensors, but it should be programmed and it should be enabled with proper data set for understanding its environment and itself. So the motors that create motion in a robot articulates or a motor which is the motors that creates motion in the robot articulations are called as actuators. These generally are of five types of actuators used in robot projects or robotics. So I'll be sharing about these five types in the later slides. So here are a few images which I want to show you here. So these are the actuators. They are nothing but the motors. So these are few types of motors or a few types of actuators which I have mentioned in this image. So stepper motors, servo motors, hydraulics, and pneumatic and DC motor, and also the AC motors. There are many number of actuators being developed currently. Types of actuators can be separated into two categories based on their energy resources and based on just a general types. So general types you can call, as I shown in the image, DC motor, servo motor, stepper motors, linear actuators, and solenoids. These are general types of actuators. And based on energy source, we have divided the actuators into four types: pneumatic, hydraulic, piezoelectric, and some miscellaneous also. So I think you could remember these actuator types, which few I have mentioned in the earlier sessions, in the session 1 and 2, pneumatic and hydraulic, how it works and what is the difference between them. Because based on the energy source means pneumatic in the sense the energy source there is the air. And in the hydraulic system, in the hydraulic actuator, the energy source is being an hydraulic fluid. It can be water, it can be any kind of oil, or generally we call it as an hydraulic fluid. So we'll be looking into each of few types of actuators in detail in this session. I hope you could see the image of what a DC motor looks like. So DC motor's output shaft is often mounted on to a pinion or spur or any other type of gear. So you don't need to be worried, or you don't need to be so confused what a pinion and what a spur or what type of gear it is. So as you could see in the image, there is a white projectile outside the main body. You could see a small white gear. That's the small gear which we call it as uh, mini gear or a micro gear which is attached to the motor, and the stick which is popping out from the main body of the motor is what we call it as an pinion. That's how it looks. So it is generally geared to an electronic speed controller that sets the motor speed and direction of a rotation. So DC motors like or other actuators which are available in variety of sizes as you could see in the image, and it also have a variety of torque handling characteristics. Torque is nothing but an integration of force, we could say, or not only integration of force. It is torque is nothing but a force which we will be calling when an object is in rotation. So you just make a note of these and you Google it, or if you are an engineer student, you would have understand what a torque is. So don't need to be worried about it because it is all so technical, but you don't need to study all those. But I'll be explaining what a DC motor and how they are being used in this session. Not only the about DC motor and about a few types of actuators also. So DC motors come in variety of spaces, sorry, shapes and sized. Although most of them looks like a cylindrical. As you could see in this image, most of them look like a cylinder. So that's the common shape of an DC motor. But there are few motors which will come in different shapes also. So their future and output shaft, which rotates at a high speed, usually in the range of 5,000 to 10,000 RPM. So although DC motors rotate very quickly in general, most of them are not at all strong. That means it has low torque. In order to reduce the speed and increase the torque, gear can be added. So that's the purpose of gear. So to incorporate a motor into robot, you need to fix the body of the motor to the frame of the robot or chassis of a robot. So DC motor can operate in clockwise direction and as well as counterclockwise rotation. So the angular motion of turning shaft can be measured using an encoders and potentiometers. I'll be explaining what an encoder and potentiometer in the later on slides. When we talk about sensors, we will encounter about encoders and potentiometers. So the points which you need to remember now is that DC motor can operate in both direction, clockwise and counterclockwise, and their range is between 5,000 to 10,000 RPM. So these are few features which you need to remember in order to use a DC motor or any kind of actuator to your robot. So now let's look into servos. So broadly, servos are used everywhere. Like there are actually two types of servo in general. You can call it as an hobby or RC servos, and another one is the industrial servos. So servo is nothing but a component with the DC motor. So output shaft and control circuitry are packaged into one single unit. So servos usually provide rotational movement, except for continuous rotation servos variant that can rotate 360 degrees. So there are, as I said earlier, there are two types: RC servos and industrial servos. So RC or hobby servos are types of actuators that rotate to a specific angular position and were classically used in more expensive remote controlled vehicles for steering purposes and controlling the flight surfaces. So now that they are used in variety of application, the price of hobby servos has gone down significantly, and the variety has been increased, like the sizes of servos and the technologies used in the servos, and also the strength of the servos. So the common factor to most of the servos is that majority only rotate about 180 degrees. A hobby servo motor actually includes a DC motor, a gearing system, electronics, and rotary potentiometer in order to measure the angle. Because previously in the about when I was talking about the DC motor, the angular motion of the DC motor shaft can be measured using encoders or potentiometers. Same goes in for servos also, where a potentiometer or an encoder is being inbuilt in the RC servos or the hobby servos in order to measure the angle. So these servos are generally have three wires, as you could see in the image, which is bit hazy there. Like you could notice three wires coming out of the motor. So these three wires are for ground and voltage purpose and for control purpose. Like two wires are for positive and negative terminals, and one wire which in general looks yellow color is used for the control pulse in the sense it will be attached to a microcontroller or any kind of controller, and the angles or the command were given from the controller to the motor through this yellow wire. In general it is yellow, but the color may be different for different servo motors. So the control pulse is actually generated with a motor controller. A robot servo is a new type of servo that offers both continuous rotation and position feedback. And all servos can rotate counterclockwise as well as clockwise. So now that about servo motors, let's look into what an industrial servo means. So an industrial servo is controlled differently than the hobby servo motor, and it is more commonly found on very large machineries. An industrial servo motor is usually made up of large AC motor, which is sometimes three phase, a gear down, and an encoder which provides feedback about angular position and speed is also um, comes in within an industrial servo motor. So these motors are rarely used in mobile robots because of their weight, size, cost, and complexity. Because these servos are generally very large, and they provide a very high cost and complexity, and they also weigh a lot. So you might find an industrial servo in more powerful industrial robotic arm or very large robotic vehicles. Now let's look into the next type of actuator, the stepper motor. As you could see here in the image, that's how an stepper motor works. And a stepper motor does exactly as its name implies. It rotates in a specified steps, actually in specified degrees, as you could see, bit concentrated over the motor. It moves with a specific degree actually. So the number of degrees the shaft rotates with each step or step size varies based on several factors. Most stepper motors do not include gearing systems. So just like DC motor, the torque is often low. So config properly, a stepper can rotate counterclockwise and clockwise and can be moved to desired angular position precisely. So the main advantage of having a stepper motor is that the precise angular position can be obtained because it moves with specified degrees, or the steps which it takes the turns is based on the degrees which we give. The degrees in the sense angles 0 to 360. So stepper motors are often used in 3D printers, CNC machines for its high accuracy and repeatability. It is often where a low torque output is also sufficient. So in general, stepper motor is nothing but a hybrid between DC motor and a servo motor. Because as like DC motor, it doesn't have any gearing system and it provides low torque, but like a servo motor, it provides an accuracy, and this is bit higher accurate than a servo motor. Now let's talk about the linear actuators. Okay, so linear actuator is similar to servo but provides linear motion. It is often through linear mechanisms such as warm drives. So warm drives, mechanical guys know obviously what an warm drives is. And please do make a note of it if you don't understand what a warm drive is, because if I explain a bit about it, it will take much more time, as I have lot of this scope to complete in this session. So a DC linear actuator is a type of linear actuator which I'll be concentrating as of now. So it is often made up of DC motor connected to a lead screw. So as the motor turns, so does the lead screw also turns. A traveler on a lead screw is forced either towards or away from the motor. So essentially converting the rotating motion to a linear motion. So that conversion happens here. I mean the rotation to a linear motion. So some DC linear actuators incorporate a linear potentiometer, which provides linear position feedback. I mean, which means that a linear potentiometer is used for measuring the position of the lead screw or the position of the actuator. So as you could remember in the earlier slide, I mentioned about encoders and potentiometers. So those are used to measure the angle and distance. And that's what feedback means. So in order to stop the actuator from destroying itself, many manufacturers limit a limit switch at either end, which cuts the power to the actuator when it was pressed. So DC linear actuators come in variety of sizes and strokes and in the different forces also. So the next part is about the solenoids. As you could see in this GIF image which I have shown here, that's the example of a solenoid, and I mean the working principle of a solenoid. And it is actually a specific type of linear actuator actually, so that can assume binary positions, which means off, on and off, or open or closed. So only these two binary positions or binary feedback is being done by solenoids. Solenoids are composed of a coil, as you could see in the GIF. It is wound around a mobile core, and that's the silver thing which looks like a cylinder. And the core is being pushed away from the magnetic field and produces a motion in single direction. So that's the thing happening in the uh, GIF which I have mentioned here. So the core is being pushed away from the magnetic field and produces a motion in a single direction, and multiple coils or some mechanical arrangements would be required in order to provide motion in two directions also. A solenoid stroke is usually very small, but their respond speed is very fast. The strength depends mainly on the coil size and the amount of current passing through it. So solenoids are typically used in applications like valves, latches, locks, pushing buttons, and are usually controlled by external microcontroller. So these types of actuators are generally used for on or off purposes, or more to be precise, it is for binary position purposes. So what can robots sense that humans can't? That's the first question which we need to think. Because although a robot cannot tell you if a substance tastes good or if an odor smells bad, the steps involved in analyzing the chemical composition can give it far more information than a normal human being. So a robot equipped with a carbon monoxide sensors, which would be able to detect carbon monoxide gas, which is otherwise colorless, odorless to humans. So these types of sensors or these types of purposes where human cannot sense few things, those areas where robots come into play. So a robot would tell you, like, would also able to tell you that the pH level of a substance to determine if it's acidic or basic, or much more. So a chemical so take for example a chemical company or an industry where more of acids are being used, or even in the research and the research labs, most of the industries or research labs use these kinds of sensors in order to smell or find those gases or the pH level of the liquid, which has which is which is you help for use H is used to find whether the liquid is being highly acidic or basic, or we can determine the exact precise pH value. And in cases also, like, which few gases can be detected by using a robot, which could be hazardous for humans and as well as odorless. Okay, so using pair of eyes to get a very good sense of depth, though for many, accurately gauging distance is not easy. A human might tell you the tree looks to be about 50 feet away. So, but a robot equipped with the right distance sensors can tell you that the tree is exactly 43.1 feet away. So additionally, robots cannot only sense but also can give the accurate value of very variety of environmental factors that humans are otherwise unable or even incapable of sensing. So, for example, a robot can tell you the precise angular or linear acceleration it is subjected to, while the humans would generally tell you that I'm turning, I'm moving, or I'm just running around the street. So a human can tell you based on the experience if they think that object will be hot or cold without actually even touching it. Whereas using a thermal camera, a robot can provide a 2D thermal image or whatever it is in front of. So, although humans have five main senses, robots can have almost infinite number of different sensors. It's completely dependent on us. So, like, if you are sorry to mention this because some may be atheist, some might be theist, but I want to mention that if you guys believe in God, God created the humans with giving the five senses, and we live with it, and we understand the environment, and we completely and continuously evolve by in a time period. So that's how the same robotics is going to work. So we, our humans, are going to build and produce robots which have n number of sensors, and we could just grant it whatsoever of amount, and we could use it for the benefit or for the good of humans. So that's it and done. Now we need to think which type of sensors do my robot actually needs. So what types of sensors are available and which ones does your robot actually needs to serve its purpose? You need to first ask yourself, what do I want or need to the robot to measure, or to the main purpose of robots, and what are the different types of sensors which should be attached in a robot in order to completely the in order to ensure that a robot completely understands the situation. So there is a good chance what you have in mind and will not fall nicely into these categories. So we just break down the types of sensors into bit different parts, starting on with contact type of sensors. Under contact type of sensors, I'll be discussing about few, and under the distance sensors, I'll be discussing about few, and like that, I'll cover up the maximum and the most important sensors in this session. So push button or contact switches, buttons, and contact sensors are used to detect physical contact between objects, and they're not restricted to humans pushing buttons. So pumpers on a robot can be equipped with momentarily pushing buttons, and whiskers, which is like the cat does have a whisker, so that can be used to sense multiple distances. So there are few advantages and disadvantages, like it is low of cost, it is easy to integrate, and it is more reliable than any other types of sensors for contact, and it is single distance measurement. The next would be we'll be discussing about the pressure sensor. So as you could see in the image, that's an example of pressure sensor. And unlike a push button, which offers one or two readings on or off, a pressure sensor produces an output proportional to the force that is being applied to it. So that's the main working principle here. So how does a pressure sensor work is nothing but so simple. If you're pressing or if you're giving certain amount of force into the sensor or on the sensor, it reacts directly or it reacts proportionally, and it senses how much pressure or how much force is being applied on it, and it produces it the force as an result. And we call it as a feedback. Feedback is nothing but getting the points from someone and using it. So here are a few advantages, like it allows gauging how much force is being applied, and few disadvantages are like it can be impressive and more difficult to use than simple switches. So it cannot be used as the normal switch which you use in your house. Like it won't be a binary 0 and 1 household switch. I think when we talk about sensors, I have had a few lines about the switches also. So about the distance sensors now. So ultrasonic rangefinders are a type of sensors which use acoustics to measure the time between the signal is sent from the sensor and versus when it echoes is received back. So the ultrasonic sensors release an sound or signal which reflects on a body or an object and comes back to the sensor. And with the time duration, the sensor senses the distance between the object and the sensor. So as you could know, that is what the primary flaw formula is: speed equal to distance by time. Okay, here is the infrared sensor. So infrared light, which as we saw in the is used in communication, like you could have noticed the small ray which comes out of your TV telephone. Sorry, I'm sorry, that's TV remote. So some infrared sensors measure one specific distance while other provide an output proportional to the distance to an object. So that's how the working principle of an infrared sensor works. Now let's move on to what encoders are actually about. I have mentioned in the previous slides in DC motor and even in stepper motor, I have mentioned about the encoders. And here's where we explore it. So one common type of sensor, I mean the encoder is that optical encoders. So they use mini infrared transmitter and receiver parts, and it sends signal where the infrared beam is being broken by a specific design, spinning disk, or even an object in the public. So the number of times the beam is broken corresponds to the total angle traveled by the wheel. So I'll repeat that line because it is bit important. The number of times the beam is broken corresponds to the total angle traveled by the wheel. So I think that sums up everything about encoders. So knowing that radius of the wheel, you can determine the total distance traveled by that wheel, and what are the areas that you have covered or anyone who's related to you have covered without your knowledge. You can check it out using an encoder. So this is the linear potentiometer. It is also called as an resistive band. So a linear potentiometer is able to measure the absolute position of an object. So a resistive band changes resistance depending on the force it is being applied. So if you're moving on a bike and an inspector calls you and check it out your gear speed or running speed or even your the band changes or any other problem. So whatever it is, there is going to be a huge demand for this technology. And I have mentioned the advantages and disadvantages of it here also. Now, let's talk about what stereo camera setting is. I mean, the system is. So a stereo camera system, just like an human eyes, two cameras are being placed a distance apart, and they can provide the depth of information and robots equipped with camera can be used some of the most capable and complex robots produces. And the camera combined with the right software can provide the information about the color and the object that it sees. Okay, so just as I said earlier, sensors need a set of program or codes, and it also needs a certain level of database in order to identify and in order to work, or even the cameras work only when it is connected to an controller. Okay, the next main type of sensor is that based on the environmental condition. So let's start with light sensors. So a light sensor can be used to measure the intensity of light source, or maybe it is natural or artificial. Maybe usually actually it is a resistance in proportional to the light intensity. So how does that word work means? The amount of sunlight it passes through its body, it just cut down and release it, and that's how the remaining part of the signal is being captured, and the position or the wordings or even the whatever the environmental factors are, they all being considered with the light sensors applications. The next type of environmental conditional sensor is that the sound sensor. So a sound sensor is essentially a microphone which turns a voltage proportional into ambient noise level. So more complex board can be used for the data from microphone to speech recognition. So you could see a few examples of how and sound sensor looks like. So covering up about primary types of sensors and actuators, and we have also talked about the sensor based on their environmental use. Now we'll be looking into few of the miscellaneous sensors which are in steady growth and which have been used in high-end models. So first, let's start with voltage or the current sensors. So current and voltage sensors do not do exactly as their name describes, because they measure the current or volt of a specific electric circuit. So this can be very useful for gauging purposes, because how much longer your robot will operate, like the means of voltage and pressure. I mean, sorry, battery. If your motor are not working too hard, then it is a problem with the current part. Okay. Now the next miscellaneous sensor which we'll talk is about the magnetic sensor. So magnetic sensors or magnetometers detect magnetic objects and that can either require contact with other subject or be relative close to an object. So such sensors can be used on the autonomous lawnmower to detect wire embedded in the wire lawn. So that's the primary robot which are built to use it. So most of them are being used in abroad than India. As you know, as you could know already, the sufficient number of gardens are not being provided in India for these robotics purposes. Now, so the next would be about the vibration sensors. So vibration sensors detects the vibration of an object by using potentiometer or any other technologies. So everywhere when I talk about the potential meter or environment or even just robotics subject, so those all cover in the main subject called as the vibration. Sorry, the magnetic sensors. So talking about vibration sensors, it detects the vibration of an object by using piezoelectric or any other advanced technologies. So next, I finish up with mentioning about RFID sensor. So this type of sensor is used for identifying the devices which uses active or passive technology. I mean, it can be powered or can not even power, like it can be a static object or it can be a moving object. For both of the objects it can be used for identifying. And RFID tags, usually the size and shape of a credit card or the flat disk or addition to a keychain. So these are the sizes or tags where the RFID tech is being used. So when the RFID tag comes with a specific distance of RFID reader and a signal with a tag's ID is also being produced. It's more or like a QR, but not a QR code. It looks like it an RFID technology being adapted in those kind of QR codes, and that's called as RFID tags.